Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Engineering Principles for Permeable Pavement. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Brickworks. Brickworks is recognised globally as a leading manufacturer of quality building products, including bricks, blocks, retaining walls, pavers, natural stone, wall cladding, facade systems, roofing, and so much more. Our brands continue to build their reputation for delivering quality and lead the industry through style and product innovation, creating impressive materials designed for inspiring built environments. We thank Brickworks for their continued support. In today's session, we'll feature two speakers followed by our live audience Q&A, and I encourage you all to please send your questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Joe Laspina. Joe is the Senior Principal Stormwater Engineer at Woolbridge Gilbert Aztec, WGA, where he also serves as the Group Technical Lead for Stormwater and Water Sensitive Urban Design. With over 30 years of experience, Joe has contributed to civil projects of all scales, from land development and public realm initiatives to environmental remediation and major city shaping infrastructure. His expertise has taken him across Australia, New Zealand and Eastern China, where he has contributed to initiatives such as the Sponge Cities program. His innovative work has earned multiple state and national awards, a testament to both his technical expertise and industry impact. He contributes to the field through his roles as Chair of the Civil Engineering Advisory Committee at the University of South Australia and as a member of the Water Sensitive South Australia Committee. Please join me in welcoming Joe Laspina.
Well, thank you for the introduction. I'm Joe Laspina from WGA Engineers, and I'll be presenting the segmental block pavements, permeable pavements, and I'll be covering the design principles, considerations, and its applications as well. Okay, so a presentation outline. First of all, I'll just cover off some key points about just setting the context of my presentation. Then I'll go through permeable pavement and I'll outline how it's really part of a solution to give you a bit of confidence in specifying these types of pavements. Then I'll go through how it's a stormwater management technique, and it's a very important technique at that. Then I'll go through design principles and considerations. So you'll pick up quite a bit from that. And then I'll finish off with some case studies and applications and how it's been used in the past. Okay, so setting the context here. So this presentation is geared towards an outline of the benefits, how we can go towards addressing stormwater management problems. It's in an urban context, a development context, covering off the design principles and considerations that you need to really think about as part of your design and your application. And on that, just outlining some applications through case studies. And I just want to preface this presentation by saying that I'm not here to endorse any specific brands or types of segmental block pavements. Having said that, you can see an image on the right. That's one that I tend to favour. I'm not going to say what it is. I'm sure you'll work it out. But there are many different styles and types presented here in this presentation that you'll also pick up on as well. Okay, so permeable pavements, it's part of the solution. So what are the typical stormwater management problems that we need to solve? Well, typically in an urban environment, in particularly the older urban areas of our major cities, there's a lot of urban infill development going on, and this really poses quite significant challenges to our urban drainage networks. It's these older areas that are typically prone to flooding. They already have stormwater management, flooding pressures as it is now. And that's only going to increase with urban infill, and we're seeing that already. So how can permeable pavements form part of the solution to solve these urban drainage problems? Well, the short answer to that is permeable pavements are really an effective source control measure, and I'll cover that in a bit more detail in the following slides. So you just need to bear that in mind. You're going to hear that theme repeated several times. So it's an effective stormwater management tool. It's important to note, and not many people realise this, but it's part of a key component of water sensitive urban design. Most people look at water sensitive urban design as green infrastructure, but in fact, this is actually a key technique in that. And as I said, it's an effective source control measure. You're going to hear me repeat that several times. So in that regard, it's effective at peak flow attenuation. It functions as a detention system and a retention system. I'll cover that a bit more. But as a detention system, and you'll find it's more effective than your conventional rainwater tanks or underground tanks and detention basins. And I'll explain why in the next following slides. It also provides effective stormwater treatment as well at source, simply through the filtration process that you get through the media beneath the pavers. There's a process there of filtration, absorption, and also you do get a bit of biological activity as well, which digests some of those pollutants as well. And I mentioned on-site retention. So these systems can be used as an infiltration measure into the underlying soils. So quite effective at volume reduction, achieving volume reduction targets as well. So permeable block pavement pavers actually have a high infiltration rate. So from direct rainfall, they have a huge capacity to infiltrate high intensity rain events. And we're talking up to, depending on the style of paver, we're talking up to a 1% AP intense storm, where you're not going to get any runoff generated off a surface. And basically these pavements effectively stretch the hydrograph. They create such a long release of continuous stormwater flow as a trickle flow. So they really stretches out the hydrograph, and I will show that in a moment. So here are the hydrographs for comparison. So on the left, we have a conventional hydrograph. You can see the peak flow from the post-development hydrograph, and then you can see the double-lined hydrograph, which represents a conventional detention basin or underground tank. And you can see if generally it's matching pre-development peak flow runoff, but it does nothing to reduce volume. And you can see that bell curve is fairly, it stretches out, but it's fairly pronounced, but it does little more than really attenuate the peak flow. On the other hand, the other hydrograph on the right-hand side, you can see the peak curve again for the post-development situation. And then effectively, you can see that long, shallow curve. And that's effectively what a permeable pavement does. It releases that water quite slowly over a very, very long period of time base. So it is quite effective at reducing both volume and peak flow. Okay, so some design principles and considerations. Typically, the pavement comprises of the following key components. You've got the segmental paver on the top, and they come in different styles. There are some that are structurally interlocking and others that more or less are not an interlocking style paver. I tend to favour the structural interlocking pavers because they offer superior performance from a pavement loading perspective, and also less prone to lateral displacement. Then that basically is underlain by a material of 2 to 5 millimeter screenings. And I will note there is no geotextile underneath those screenings. Some of you may be aware of that, but that was a change that was made a few years ago. You rely on the grading of the layers to prevent migration of the finer material into the underlying coarse materials. And then you've got the base materials, and essentially this is a gap-graded crushed rock base, which provides the majority of the structural strength, but it also incorporates about a 20% void ratio, which is the volume of those voids is what really holds your storm water and releases it slowly into the underlying sublayers. Then you've got the subgrade, and it's very important that you consider those characteristics of the subgrade, and I'll cover that a little bit more in a moment, because this is no different to a normal pavement design. Obviously, you need to consider your subgrade. Then there's the liner, and in this regard, you need to consider whether you're going for an impermeable liner or a geotextile liner to allow for infiltration. Again, these are key considerations. It depends on your subgrade, your constraints, and what you're seeking to achieve as well. Within this pavement, also, you're going to incorporate subsurface drainage collection pipes. This is a perforated pipe, which essentially transports the seepage water away to your outlet. On the right-hand side there, you're not going to be able to read that, but that's just on one project. We had different combinations of permeable pavements on a project. There's a bit of detailing involved in that, but it's a fairly thorough approach to designing permeable pavements. Okay, some more considerations and principles, mostly in considerations. So there are different types of paver types. Some offer superior interlocking structural performance or properties for heavier loading situations. And then there are other types for low loading conditions. So you need to choose carefully what type of application you're selecting your paver for, and obviously you need to speak to your supplier to understand what those properties are and what you're seeking to achieve. With regards to loading, you need to consider construction and also in-service loading conditions. You need to design obviously for the worst case. As I said, this is no different to a normal pavement design. But I will also say that you need to consider the volume of water. If you have a detention or retention target in mind, you also need to consider the overall thickness to design to those parameters as well. So whatever gives you the biggest thickness is obviously what the critical design is going to be in this situation. So in terms of pavement design thickness, there is software available, and it depends on your supplier and manufacturer who can give you that information to design your pavement thicknesses as well. There are some suppliers that have that information. Okay, so a bit about subgrade conditions. So you need to consider whether you're dealing with reactive or heavy clays. You need to consider if you're close to buildings, because you don't want to impact buildings or structures if you're looking for an infiltration type solution. Surface gradients is an important one because these typically don't suit steep grades. And sediment loading is a very important one, and I'll cover that a few times. You'll hear that because that's a very important consideration. Sediment loads can quickly clog your pavement, but I'll cover that a bit more in a moment. And I did mention construction traffic versus in-service loading as well as an important consideration. So there's a bit there to think about that needs to come together in the design. Okay, so maintenance considerations. Well, first of all, these pavers do need to be cleaned periodically, and that can be done by a broom truck or a vac. But depending on your paver installation, if you've got screenings in the joints between in the gaps, then you need to replace that filling stone periodically every few years. Depends how much stone is actually lost. It also depends on the amount of debris that you get um, from whether it's in a leafy area or whether it's prone to sediment load and that sort of thing. But a little bit on sediment loads, you need to consider the short term and long term loading of sediment on these pavers, because that's really what's going to shorten the life of permeable pavements is in fact sediment loads. So think about that quite carefully, particularly during a construction period. If you've got house construction, that needs to be thought about quite carefully, because that's what's going to shorten the lifespan. But generally, on lifespan, under normal urban runoff conditions, a typical permeable pavement will last 20 years. And I'm referring to not pavement strength, I'm referring to clogging of the pores or the gaps. So with a well-maintained pavement, you can probably get more than 20 years. And having said that, it's possible to renew these pavements and reset the pavers and reinstate full performance. And you do that by removing the pavers, replacing just the top layer of stones, and basically you've got a new pavement again, and you've got your full asset life ahead of you after that. Okay, so now just covering off some applications through case study examples. This is one at Forestville. It's a high density urban infill development in Adelaide. And this is located in an old area of Adelaide. It's an established area, so there isn't much in the way of urban drainage network. The area is already prone to a little bit of flooding. So here we've got a proposal to infill a parcel of land with approximately 60 townhouses. And what we've got here is basically the road network has been designed using permeable segmental block pavements. So we've got a combination of infiltrating style pavements, which are just lined with a geotextile, and we've got one that's fully lined, which is on the left-hand side, which carries a lot more traffic, the one running up and down the screen. That has an impermeable liner. This is what it looks like. As you can see, the street network completely permeable pavement. So effectively, this is going to manage all the stormwater, majority of stormwater, I must say, within the development itself, and reduces the impact on the adjacent existing infrastructure, and avoids creating a nuisance and flooding, increasing flooding impacts on adjacent areas. Incidentally, also on this slide, you can see on the right hand side and on the left, you can actually see there are pockets of landscaping, and those trees will actually benefit from using the permeable pavement because it provides a source of passive irrigation. So it's a good way to provide good, healthy treescapes in an urban setting. Okay, so car parks. This is a typical one. Car parks, I have to say, this should be a standard application for all car parks. This one is at the University of South Australia at Mawson Lakes. And basically, yeah, these are infiltrating style pavements. And I just want to draw your attention to the image on the right-hand side. That's just an aerial shot of the new building. The car park permeable pavement is just in front of that. And we've designed part of that permeable pavement as a stormwater harvesting system. So the way that works is we've got relatively clean water that will be intercepted from the roof drainage that is basically captured and conveyed into the permeable pavement. So the permeable pavement has been designed as a storage tank, essentially. And then what we've got are a series of landscape beds in amongst the permeable pavement, and with solar pumps, we actually extract that captured water to irrigate the landscape beds. So it just shows the versatile nature that you can achieve with permeable pavements. And this project is innovative in that it was the first of its kind to implement permeable pavements as a storage media for stormwater reuse. Footpaths. This is very good for street trees. A lot of urban councils are now using permeable block pavements for footpaths, and for obvious reasons, that's going to provide a good source of rainwater and oxygen to the street trees. So quite effective, and it obviously reduces runoff to the street as well. Okay, this one here is a roadway in Hawthorne, just south of Adelaide. Um, Basically, this was retrofitted into an existing street. It's quite a wide tree-lined avenue, and basically council constructed a permeable pavement along the parking bays, and this is quite effective at reducing runoff into the stormwater system, but more importantly, provides a source of water and irrigation to those large, beautiful trees within that street. But one thing we need to be aware of is the clogging risk from the tree litter. So this image shows that permeable pavement is fairly clean at the moment. I've been past there a few times and I've seen a lot of debris, and that really risks blocking the gaps within the pavers. So look, it's working quite well, and as I said, it's quite effective at providing passive irrigation and oxygen to those significant trees. Okay, freight terminal. So permeable pavements, you can actually apply them to heavy industrial applications as well, as you can see here with those images. What I will say though is obviously structural loading is very important, but also the mechanical structural interlock that you get into a paver is very, very important here, because with heavy vehicles, forklifts and trucks and the like, you're going to get a lot of lateral forces acting on those pavers. So you're going to need a paver that's got significant structural interlock so that you prevent and restrict that lateral rotational movement of those pavers. And that's also another reason why you wouldn't want to use a geotextile liner beneath the screenings, which will effectively create a slippage plane. So just a couple of things to be aware of there. But yes, you can use these in very heavy applications as well. Okay, so just summarizing. So it's a proven and effective technique to manage stormwater runoff at source. Very effective. Provides a holistic approach to stormwater management with regards to peak flow attenuation, volume reduction, and stormwater treatment as well. And I've already shown you, you can enhance urban greening through using these systems as well. It's important to note it's a water sensor urban design technique, and it certainly goes a long way to protecting our natural and built environments. Thank you.
Thank you, Joe, for your input. I'd now like to welcome our second speaker, Andrew King. Andrew is a civil engineer with experience in all levels of government and private practice, currently employed as the Business Lead Engineering Services with the City of West Torrens in Adelaide. As a long-standing chair of Stormwater SA and a member of many state and national stormwater reference committees, working groups and networks established over the past decade, Andrew is consistently pushing for better practices, capacity building, guidelines and legislation in relation to stormwater management, water-sensitive urban designs, public infrastructure and related fields. Andrew is keenly mindful that as engineers associated with public works, we are physically shaping and delivering the public spaces in which our communities work, live and play. Our actions today will leave a generational impact on the value and benefit communities gain from these spaces. Please join me in welcoming Andrew King.
Thank you for that introduction. And I guess I'm here to talk to you about permeable pavements. Probably going to make my presentation a little bit less technical and probably try and put you to sleep with example after example of how you can practically implement permeable pavements. The title has a bit of a ring to it, but at the crux, it's what I want to try to instill today, that permeable pavements are more complicated than we think, but realistically, they're complicated in a simple way. And once you have a basic understanding, they're easy to implement. Sounds confusing. I hope to aim to unconfuse. A little bit about who and where we're from. I've been working with the City of West Torrens for about 25 years. We're at Metropolitan Council in Adelaide, between the city and the sea, so in a metropolitan, well-established area, not overly large council, and not a lot of no greenfield development and isolated brownfield development. Lots of infill, lots of population growth pressures through that infill, and probably one of the other notable elements is that in relationship to current conversations of urban tree canopy cover, we're relatively low on the scale of that. So one of our challenges is to increase urban tree canopy cover, and permeable pavements are a great complementary element for that. Where do I come from? I'm a civil engineer. I come from a water background, lucky to be influenced through my career by many of what I would consider South Australia's leaders in stormwater management, and also some who are nationally and internationally recognised for their advancements of stormwater. Water sensitive urban design is a passion of mine and has been for at least the last 15 to 20 years. And we like to think that at our council we're pretty show that leadership. And again, that's how I came to permeable pavements being one of the tools in the toolbox of stormwater management and water sensitive urban design elements. And I guess if I can instill something in you today is that, it is a tool in the toolbox. It's if you understand the how, the where, the why of use of permeable pavements, then you can bring them out at the appropriate time and place to achieve the objectives that you want to look at on a particular project. So why are they complicated? I think we use the term permeable pavements very broad-reachingly without necessarily always thinking of what is actually going on and, again, what we're trying to achieve. Just simplistically there's three categories of use. You can infiltrate, detain, or retain. You can have them in light, non, or heavy trafficked areas, and you can either soak in just the footprint that you're working with or footprint from a greater area. Now, simply just by that, there's 18 different permeations of use there, and not every installation is going to be singular of that 18. Quite often you'll amalgamate multiple elements together at the same time. So that's where there's such flexibility of the use of permeable pavements. And I think that quite often permeable pavements are spoken of in a very simplistic manner as far as utilisation. There are lots of whys, and I'll let you have a quick look at that screen. That photo is a genuine urban creek in our council area from several years ago. Luckily, it doesn't look like that anymore. I don't think anyone can honestly sit there and say a creek should look like that. And how we manage our stormwater before it gets to a creek like that is completely in our controls. As engineers, I like to consider that we engineer the localities in which our communities live. And if we don't engineer them correctly, the communities don't have great places to live. How do we get started? Well, this was a project where we had a road reconstruction. We had this entrance to a golf course. It was a feature entrance, and because our city is on the original floodplains, everything in our council is ridiculously flat. But this particular location, a civil designer couldn't get falls to get conventional drainage to work. And after spending 3 or 4 days on the design and manipulating things, we sort of had a bit of a chat and realised, well, this is a pocket of our council which was pretty sandy. And so if we had developed a solution where the water didn't have to go anywhere, it could drain through the permeable pavement, then it didn't need to have grade. It effectively could be established as being flat. This is one where we encourage the water to drain away and infiltrate. Predominantly collected just the catchment of water that landed on it, and it solved the problem that we had at the time. I'm not going to go through a lot of design side of things, but I'll probably have 2 or 3 take-home design messages. One of those is that when we did this, we lent on what we could find as available information and guidance of standard details. A lot of standard details, and quite commonly out of European utilisation of permeable pavements, is the establishment of a geotextile layer just below the fine stone bedding course of the bricks. That we've determined over time is actually a big no-no. It effectively provides a shear zone, and so when you've got movement, particularly in trafficked scenarios, so not to be used in traffic scenarios, shear zone, and you can see there the movement. Those bricks have moved over, have shunted, over 100 mils or thereabouts, completely mucked up the pattern. And obviously then the strength of everything else going on as well. The geofabric was originally thought to benefit sediment control, but again, that's been well shown as not being a factor at that depth in the formation. We changed that over 2018 to a better interlocking paver, basically, and we only had to remove down to the geofabric layer and reset from there, and we were good to go from that. That's been perfectly fine since then. Another small learn if you're using the Trihex style paver as that one is. Align them all in the same direction. You can see from that pattern that they're what I call top to tail, which actually means that you lose some of the interlocking nature. You look, in the angle of that image, you can see the straight lines parallel with the road, where you're not getting the full interlocking benefit of the paver. Next project I'm going to show you is a laneway. It was an old dirt laneway. Unfortunately, it's one of the few parts of our council that has some topography. That lane was a no-through road laneway, but the road at the top end of that, as you see on the screen, is actually quite higher than the lane, which is mostly flat at the bottom end of the screen. As the properties through there added garages and extensions, a lot more water was pushed to the laneway. Became a drainage problem. The property at the end of the laneway wasn't interested in facilitating an easement for us to give us somewhere for water to go. So we went for a permeable pavement solution in this scenario to give us a tanked storage underground, was one of the purposes, that we had a pump system to take it back up to the street at the end. But the other element that was great about permeable pavements was, again, not having to follow conventional rules with regards to curb alignment, drainage, curb falls, pavement cross falls along the laneway. We had a lot of close-built garages and sheds at multiple different levels that had no consistency. So we were able to flip-flop the crossfall of the laneway and not have to have curb lines that went from end to end, so that we ended up having something that matched the landscape quite well. You can see there the excavation, the core gravel and the under drainage going in, and what it looked like as a finished product. And again, it's picking up there that our ability to match really well with multiple challenges of edge constraints and controls. Probably we're not alone with issues of the past where you have something like a river red gum tree and there's 3 of them in the street that were there before there was any suburbia in this location, but for some reason, future people in our roles decided to build roads around them. Again, common sense in the current day and age, this is not good for anything. this sort of arrangement. The road was up for rejuvenation. So we basically looked at the drip line of those trees and made the road around them permeable. Not multiple benefits and wins, breathing and moisture going to those trees, making the sustainability of them into their future better. But also from the road management perspective, you get some lifts or curb lifts over time in the pavement, in the road finish surface, rather than ending up with puddles on the road that then cause cracks and drainage and pavement failures. In this location, if your road moves up and down a little bit, you've still got your drainage going through the system. Here is one of the projects that we did that had a bit of flair to it. It's an old industrial area where the road was up for rejuvenation, but it's an area where we knew that there was actually rejuvenation of the area coming as well. So the industry was potentially moving out. This is on the fringes of the Adelaide city. You can just see a snippet of the city parklands on the right of the screen. We knew the area was changing and we didn't want to put back like for like. That was the existing road, another one of these where the infrastructure has been built within an inch of the trees that were established. But we wanted to give, from an amenity perspective, we wanted to provide a street that provided more vitality to the location. We retained the trees on the right-hand side of the image there and reset the trees on the left. We built it with clues of a shared space style environment, and brought about several water sensitive urban design elements, one of which being the permeable pavements you can see there on the right. As an urban design element, this project is right next to the River Torrens, so we had the wavy line in the pavement. We used that then as the barrier between the permeable and the conventional. And one thing that most people don't notice until they're told is that wave also mimics the drip line of the trees that we retained. And so therefore, again, you're getting that good infiltration and breathing in and around the trees. Of note, the trees on the opposite side of the road are actually in biofiltration systems, individual little biofiltration systems. And all the filtered water that goes from that actually goes to an end of street storage, which comes back to re-irrigate these landscapes because we wanted to carry a higher amenity in the location. There's the permeable pavements going in, the low flow drainage soakage pipe there actually goes to an infiltration well adjacent to the trees. And the new trees that we built on that side that had the existing new trees we established, they were actually established in growing cells as well to give them good soil environment. And between the focus of the growing cells, the water regime, and the biofiltration, they're images of the trees when they're about 3 years old. They're sort of up tickling the power lines already and getting to a point where they're substantially contributing towards the cooling, the greening of the locality after only a handful of years. Compare that to a standard install of a tree, and you would still have something which would be pretty fledgling and many years away from providing benefit. So this is where the blue, the water sensitive urban design, the infrastructure assets can support the green, which is critical in urban areas and getting more cooling and greening to urban areas. Interesting of note, I was talking about rejuvenation. The shaded area onto more of the left of the screen is an old university site that's been turned over to urban development. We'll come back to that one a bit later. The site on the right, the larger site, is the former West End Brewery, which has just been purchased by the state government as a major urban renewal with apartment buildings and high density development. Both of those projects have seen that Holland Street, which we've just shown you, and said this is the standard that they're going to work to moving forward. So that's the other element of the influence that public engineering and infrastructure people can have, is you lay the basis, set the standard, and then mimic who can then help deliver further benefit. This is another facet of the utilisation of permeable pavers. Maybe one thing to digress here too, one of the things that we've done is that rather than running permeable pavers as demonstration projects or example projects, rather than that, we've tried to move the techniques and technologies, which are well proven now, they've been around for a long time, into business as usual practice. I guess as the analogy, you teach someone, you give a person a fish, they eat for a day. You teach a person to fish, they eat for a lifetime. By moving it into standard practices, by using it as a tool in the toolbox, the repeatability of installation and establishment is where the benefit comes from rather than individual projects. We did push the boundaries on this project a little bit. It's a road which came up on an infrastructure schedule for a major reconstruction. So we took the advantage of permeable paving the parking bays along the edge of the road. One of the elements in here from a water perspective challenge is that there's quite hefty catchment to the street in context with the low grade, that there was quite a bit of curb flow along the road. Now, so one of the things that we are trying to push the boundaries with here is that rather than just being the road runoff direct, which runs across the permeable pavements, we're trying to work out whether over a long extent that high curb flow can also be picked up in the permeable pavements. We know that we'll probably wear a slightly higher maintenance regime on the permeable pavements to facilitate that, because the sediment loading will be higher than a conventional design. But the benefits of not having to upgrade downstream infrastructure as quickly or to the same scale and extent plays in there as an offset. The other element that this brought about was that one of the residential concerns with this street was traffic behaviour. They didn't like some of the more heavier conventional traffic control plans, traffic control techniques that were proposed by council. So by providing the permeable pavements, the materiality difference, it gives a feel of narrowing of the road, and therefore it's demonstrated in traffic management practices that can help generally encourage the traffic to maintain slower speed. Again, not going to get a lot into detailing this presentation. One of the things that we've adopted in larger, longer extents where there's greater ability of things to move, and a bit as a belts and braces approach, we use GeoWeb in the base material just to help bind and lock that together, give it less room to move. And again, belts and braces just to make sure that it's not going to go anywhere. What's of interest is the green is the project I just showed you. The blue is a project on our books at the moment, where we're going to, in a slightly same but different manner, implement permeable parking indented bays that all of the road water drains to. Again, giving us the opportunity there to buffer the flow that's coming from this part of the system. This is part of the upper catchment. So again, the more you buffer the flow in the upper catchment, the better benefits there are downstream to flatten the hydrograph of that catchment. These systems, we have the low flow drainage in them and formal drainage out, but we don't impermeably line them. We give the opportunity for some degree of saturation of the in situ soils, because of the established tree canopy, trees in and around the area that can take benefit from that as well. Here's another capital road project, similar sort of typology, where we're taking some of the road to permeable pavements. I call this a tumbleweed road. The traffic volume on the road is not great. There's probably more tumbleweed that goes down there than vehicles. But in doing our asset management better, one of the things we look at is rationalising the width of a road. Does this road need to be as wide as it is for the parking demand and for the traffic volume arrangements to it? And what we did was made permeable indented parking bays on the reserve side and narrowed the road down to a 2-lane road. The effect of that is that we somewhere in the order of 30% reduced the asphalt seal of the road. So that's 30% asset that no longer needs to be maintained from an asphalt perspective. Yes, we've replaced some of that with permeable pavers. These permeable pavers actually don't drain to the drainage system. They drain to larger soak wells we've established in the greenway along there. So we also worked out that we've offset hard surface of the road by about 30%, which is equivalent to 10 new build houses in that street, and with a strong focus of urban infill, we're offsetting the additional pressures on our stormwater system from urban infill by reducing some of the road runoff in the locality. And there's a picture of the street as finished, plenty of width for the traffic, indented parking, and again sustaining the trees adjacent because of the additional infiltration going to them. And again, once it moves into practice as usual, green is the project I just showed you, blue is the project we're about to hit today. We're effectively selecting exactly the same typology. This particular one has a little bit more indented parking because that's a modular nature design. The demand here is greater for the parking, so we provided a bit more of that. But we still have that offset of stormwater runoff, offset of bitumen infrastructure, and realistically, the brick paved parking bays will last a lot longer than the road. So when this road is next due for, as per the last one, next due for a road reseal, there's that substantial reduction in the amount of infrastructure expenditure and the material expenditure that needs to occur with that. This image is a little more complicated, but it paints that picture of what starts to occur in a locality. The green and the blue are the two projects I just spoke to. This area is also upper catchment of a stormwater system, which is chronically overloaded at the moment. The green arrows indicate the drainage line that runs out servicing this area. The upper orange square in that catchment element is an area where we have just completed a permeable parking bay along the road, the full length of the road, providing again some wide curb flow pickup and buffering of flow. The yellow ones are roads that are due for capital improvement, where we're holding off a little bit longer on because we're involved with research at the moment with the University of South Australia to change the base mix for a permeable pavement and provide something which is more of a multi-size base, which could provide a bit more road strength. And we're potentially going to look at utilising those roads as a full road width permeable pave treatment with the aim to really hold back the water from that catchment. Again, spending the money there rather than spending the money on the sometimes near impossible task of upgrading the stormwater drainage further down. When we move towards developments, a colleague of mine once said, and we may have heard from him earlier on today, that if you can't do water urban design in a car park as an engineer, you give your certificate back. Here again, we're focusing on permeable pavements. That square there is established in permeable pavements, relatively straightforward and simple. The driveway leading into it, the bit of parking top and bottom of it drain back to that. Again, as a rough design rule, a 3-to-1 ratio of catchment area to permeable surface means that that permeable surface will last the design life that you want it to have. You will get clogging. Permeable pavements do clog, but if you design them in a manner where they're not overloaded, that clogging front, as it's called, as water from that image runs from the right side of the parking lane over the pavers, yes, that front edge of the paver will block and water will run over it, move into the next part. But that clog front will move across the depth of those parking spaces over the life of the over the permeable pavement, to the point where at the back end of life, it's going over 80% and draining into the last 20%. Yes, they clog, but clogging is designed into the way the mechanism of these work. Digital for one car park here is another. I was talking about the multiple ways you can get things to work. This particular one was part of a new building, new small community building for a tennis court that council owns. Not only is it permeable pavement, they're picking up water from the the parking area, but the building behind that photograph, the new community building, all of the stormwater runoff from that roof drains to the base of this permeable pavement, so that this permeable pavement is achieving the detention storage, the free tank underground in effect, for the building, rather than having to have some sort of additional detention mechanism taking up footprint or cost and expenditure of installing underground. A big area that we've moved into is permeable pavements in footpaths, particularly in association with new tree planting. There's an adage that the definition of stupidity is doing the same thing and expecting a different result. I'm sometimes amazed in local government circles how for example, we are challenged with relatively narrow road verges in most locations. These are quite healthy from our perspective, these verges. But we're pulling out trees in road verges because they establish conflicts between curbs and footpaths because of those narrow verges. But then we go put trees back in the same way and get surprised where in 30 years' time we've got to pull the tree out just as it hits a mature height and size because of that conflict. I'm not going to go into the detail here, but it's been clearly demonstrated in the research that the use of permeable pavements in association with juvenile trees prevents those damaging roots from occurring under footpaths and verge areas. They occur at depth, and therefore not only does the extra breathing and moisture to the trees benefit the trees, but it also benefits not having to come back and reset the infrastructure. Relatively simple and easy to do. The other mindful point here is that these being non-trafficable, we're not talking about anywhere near the depth of pavement underneath the permeable as what you would in a road environment. It is more akin to a footpath base material, and so therefore the cost variance of materiality is not excessively different. The photo there on the left is one that we did last week. We literally finished last week, and over the last month we've probably completed somewhere there at 30 to 40 trees in our standard delivery project of repaired and upgraded footpaths. The other thing to say, pick up on that, is that that's a 2-year growth of tree installed in a location where we've given vitality back. The trees in that location previously had no verge width to work with, and were the couple of trees that were in the street were destroying all the road infrastructure. Developers, I'll touch briefly on developers. Again, permeable paved in car parks, not hard to do. This is the first application we have from a particular developer. It was a lot of work for us to encourage them to do the permeable pavement in the development, selling to them the benefit of achieving the detention storage under the pavement. Effectively, the free tank idea is what got them over the line. What's curious is that you break the barrier with them in one project. This is the second project they came back to us with cross on the other side of the road, because they had been through the process 2 years earlier with us. When they originally presented the design to us, it already had the permeable paved car park design within it. Again, showing that repeatability, break the barrier, things go a bit easier. This developer was able to get additional building space on an additional small commercial unit on the development because of how they permeably treated the footprint of the tree. So it's not just environmental benefits or water benefits. Sometimes you can actually get better out of it, better economies out of it from a development perspective as well. Earlier side, I talked about an old university site that was near the Holland Street project. This is what we were able to get that private developer to deliver. Originally, they showed us a conventional laneway in a location where they were going to build multi-storey apartment buildings and high-density townhouses. We pushed them to deliver a shared space. And on the sketch below, the highlighted blue area is actually a strip of permeable pavement to drainage underneath, which has enabled this design to be established pretty flat. We've removed all of the conventional drainage language of curbs and spoon drains so that we get much better performance out of a small space. And we're not a much more greater amenity solution to a location. You can see it there during construction. On the right, we've even tried to completely hide the permeable pavement through the blending of colours, and even blending the edge of where the permeable and non-permeable pavers are used. And as long as that blend is over the permeable formation underneath, you're set and okay that it'll work. This detains all the water from the location. It cleans all the water before it hits right next to the river, and provides a wonderful spill out space with no hazards of curbs and spoons. And again, just demonstrating to the developer the cost savings on not having curbs and spoons being offsets that could be used to build this, not having to build under drainage under the street, which was much smaller scale in this delivery than what it would be conventionally. Definitely return those benefits. Another pretty picture of the site, something that's been finished in the last 12 months. There's just addressing some of the misnomers is that you can't build permeable pavements in urban legend. You can't build permeable pavements in heavily trafficked areas. You can't do it large scale. People are going to have issues with high heels on permeable pavers. This is a photo I took about 10 years ago at Olympic Park in Sydney. Large expanses of Olympic Park in Sydney are permeable pavement. Built 20 odd years ago, would have to be due to the Olympics. Consistently used for high volume of people, truck movements, semi-movements, setting up and taking away events. I struggled to find any patches of permeable pavement in that precinct that looked poor after years of use. You would have events of all nature, thousands upon thousands of people walking through the site with high heels, with no apparent record of any grand issue. And it can be done as long as the right efforts go into what's going on. I guess if I was being philosophical in a comedic way, which is probably the style I like, you miss 100% of the shots you don't take. If you start utilising it, start understanding it, you will start winning and start scoring goals. And I thank you for your time.
Thanks so much, Andrew. Loved all those case studies and that final message. Definitely, I agree with. Well, I should say it's now time for our audience to get involved. So please submit your questions via the chat box. Don't forget to let me know who you are and also who your question is directed to. A big thank you to everyone who's already submitted questions and also submitted questions while they registered for today's webinar. What I might do is kick off with some of those. So we had a question, and I might bring Joe back into the conversation. So Joe, we had a question that came through from Douglas, and the question was, does dust/silt restrict permeability? And if so, can standard sweeping trucks be used for maintenance or dust removal, or would more specialised equipment be required?
Good question, Douglas. Fine silt and sediment is generally part of urban stormwater drainage runoff characteristics. And in terms of sweeping and using a vac truck application, it will help a little bit, but that material is so fine, it's difficult to prevent that from entering into the pores of a permeable pavement. Typically, you will allow that to enter a permeable pavement during its life. It's a given fact. The key thing here to address is mostly the coarse sediment that you might get from construction loading. That's going to reduce the asset life significantly. That's what you want to try and put in measures to prevent. And also just regular maintenance if you've got a lot of tree litter, which tends to accumulate on the pavers, and it'll decompose and it'll block the pores fairly quickly as well. That's the sort of thing you got to target. As in the fine particulate matter, you don't have to specifically target that. Thank you.
Awesome. Thanks for
Hey,
that,
Megan,
Joe.
if I could just
100%
add to
jump
that,
in.
sediment and blocking of permeable pavers is probably one of the major barriers to uptake of the use because of the unknown certainty of it. And what Joe said is completely right. But from our experience, our street sweepers, the broom we tend to use as part of with normal route and routine of our street sweeping. We get them to broom over the permeable pavers. That will kick a few stones out of that top layer. We actually get them to turn the vacuum off because that can suck out more stone. And if you have that vacuum treatment going all the time, you'll probably lose the top 30% of the stone in those, particularly the wider gap permeable pavement styles, which will start impacting the rigidity and strength of the pavement. So that's one thing to be mindful of. And again, it's easy to top that up by throwing out a few buckets of small stone and brushing them through. The other thing that if you're in a more prone area to, particularly as Joe said, some of the more vegetative material getting through there, there are definitely points in time and not necessarily an annual activity, but several years apart, you can high pressure spray the permeable pavements because most of that clogging will occur, the vegetative material clogging will occur in the top 20%, 30% of the stone. And again, so that high pressure spraying can clear that out. And again, it can be topped up again, and you're good to go for a long time. When you actually do reset the pavers, it's quite interesting. You pull them out, the sediment realistically only gets to the base of the paver. You see a ghost outline of where the pavers are when you pull them up, and you realistically don't typically need to replace a lot of that base of stone. Bedding stone, you can almost just broom through it to dissipate it and put the same stuff back.
Awesome. Thanks so much for that, Andrew, and thank you, Joe. There was a question that came in from registration. It was from William from Victoria, and it was around, will permeable paving with permeable paving becoming more common, how should we manage it on a highly reactive site? Williams from Victoria, he asks, in Victoria, we typically specify in an impermeable perimeter apron to protect footings, but that can conflict with the intent of infiltration. In these cases, do you recommend engineered subsurface drainage, deeper footing systems, or a combination of both? I might ask that one of you, Joe.
Yeah, absolutely. Look, first of all, on reactive sites, you got to work with your structural engineers. Make sure you're not upsetting them, putting infiltrated water next to footings. So, in terms of designing footings to cope with that, I would suggest you'll be up for a battle with your structural engineers if you're designing it that way around. It's more about, I think, you need to put in your risk management measures, design your pavement so that you're not infiltrating water into reactive soils. Having said that, in wider spaces, if you did do that, I think it's generally okay if we're not talking soils with huge amounts of vertical movement. These pavements will tend to maintain, in an infiltration perspective, will tend to maintain consistent moisture conditions under the soil. So, the vertical movement is probably reduced because you've got more consistent moisture conditions underneath the pavement. But you also need to be mindful that in these typical clay soils, you're going to get vertical movement of clay particles through a pavement material, which will clog it from underneath. So generally, I would always use an impermeable barrier in a reactive soil. You're still going to get the benefits of the attenuation that you achieve through these pavements. You're not going to get so much volume reduction, but clearly here you need to design to the constraints that you have to deal with on any site. So that's really a take home here, is know what your constraints are, and obviously you need to risk mitigate your design.
Thanks for that, Joe. Andrew, I've got a question that I might direct to yourself. We've had one come in on registration and also one come in live. A big hello to, I think it was Joseph, who's watching live. And it was very much around, I know you spoke about your experience, obviously, in SA, but they've asked around, are there any practical or work examples happening here in Queensland? So hoping you may have some insight.
I've actually spoken to some people over the last year and a half in Brisbane, and have a little bit. I don't proclaim to be an expert in sunny Queensland, but through speaking to a few people in Brisbane, they did mention a couple of examples in Toowoomba and the Sunshine Coast, I think they were, of car park style installations. But talking to people from Queensland about the landscape of the industry and policy and planning documentation and processes, there doesn't really seem to be anything that jumped out to me from those conversations that makes Queensland anything substantially variant from the rest of the country, where predominantly it's a willingness to uptake the technique that is the barrier to more of it occurring. And I bring that back then to the willingness to understand how permeable pavements can be used as a tool in a toolbox, and that's the message I got from people that I spoke to in Queensland. The barrier is about popping the bubble and getting more and more examples going, and that rolling the ball down the hill and gathering more momentum.
Excellent. Well, the case studies that you showed looked amazing. They look so lovely. So yeah, hopefully I'm based in Brisbane, so it'd be lovely to see more of that happening. Joe, I had a question which came in again from Joseph, who's watching live, and it was around, is there a standard drawing that we may have when specifying the permeable paver?
Yeah, good question. Look, there's a lot of information available. Google's your friend, but be aware what you download. Generally, the makeup of these pavements are more or less consistent, but they vary depending on obviously your constraints and in particular your subgrades. So there isn't a standard design as such, but I will say there is a design that's more or less similar across the board with some variance depending on what you're trying to achieve in your design. So just be aware of what sort of material you're downloading from the websites.
So I can answer this one as well, Megan.
Awesome, thanks, Andrew.
The CMAA, Concrete Masonry Association of Australia, have actually developed what researchers I heard a researcher mention last week, is probably an internationally leading free software package for the design of pavements, for brick pavements. It's called Design Pave, and inside of that is Permeable software, which is actually an online engineering design tool for permeable pavements, and that can bring all those inputs in that Joe was referring to, and allowed to your soil conditions and your traffic load conditions. It has the design technique for understanding your clogging front and how to design that to get the design line out of the permeable pavement. All of that is there. It's based on engineering rigor to give you that. The other thing I'd point to is that several of the Australian manufacturers have done a lot of work in recent years of upscaling their own documentation in relationship to typical arrangements. So not necessarily site-specific depth of layers or ground conditions, but typical arrangements of what a lined permeable pavement would look like, what an unlined permeable pavement. I saw an updated brochure last week that added some detailing about if you're have a site that has some grade to it, how you can, because quite often permeable pavers don't like being on steeper grades, and a lot of the storage functionality in the base struggle. So there was a standard arrangement plan of how that would look on a steeper site. So I think there are some good resources from reliable sources that can be found in that area.
Awesome. Thank you. Joe, I might start with you, Joe, and Andrew, please feel free to jump in. There was a question which came through, which was addressed to both of you, but just asking about, to discuss more about when to specify geofabric and non-permeable sheets under the permeable blocks.
Okay. Well, the short answer is it depends on your subgrade conditions. If you've got a subgrade that permits fairly well defined or understood infiltration rate, you can generally go with a geotextile liner and allow that infiltration. However, if you're dealing with a heavy clay, then you're generally going to go with a impermeable liner. It also depends on your other site constraints. If you're near structures, land gradients, there's a whole lot of different considerations there, which I guess help to define one way or the other. But what I've just said to you are really the main considerations that you want to take into account.
Thanks for that, Joe.
So the thing I would add to that, Megan, is it also comes back to the whys, what you're trying to achieve. The footpath examples we were talking about that both of us had in our presentation, you would never impermeably line one of those footpath examples where the only water soaking into it is the water that lands on it, and you're doing it to soak those small footprints away. So a similar sort of thing can happen in urban development environments. I'm always in a to and fro with people about infill development and utilisation of permeable pavements on driveways. If you take a strip of permeable paved driveway right next to a garden bed, I would avoid putting the permeable pavement right up against a building edge in clay and reactive clay environments. And most of our council area is reactive clay environment. But if you utilise part of a driveway that's permeable pavement that is only soaking in the water that lands on it, so reducing the impervious surface of a site running off to a street, but it's only passing what lands on it, is it that much different to that part of the driveway being grass from a perspective of how much saturation you're getting of the ground? So it's that arrangement and objectives that you also need to consider. If you're draining 2 or 3 times as much water into that and making it a formal multiplied infiltration system, then your shrink and swell conversation is going to be a lot different to if it's only draining the footprint that the water lands on.
Awesome, good answers. There was a question which came through from Jeremy, and it was around, is there a risk of creating sinkholes below the street? Maybe, who wants to go with that one? Joe?
I'll go with that one. Again, it's about understanding your geotechnical conditions underneath the pavement. So it's no different to a normal pavement design. You need to do your investigations and understand what you're dealing with. Sinkholes, if you've got your advice from your geotechnical engineer says, hey, we don't want to put water into these soils because there is a risk that sinkholes will form or the material will dissolve, or if you're on a wind-blown sand. I mean, people think sands are sands. No, sands aren't sands. Some sands are collapsing sands. So again, it comes down to understanding what your subgrade, what the makeup of your subgrade is, and you design to that.
Awesome, thank you. Andrew, I had a question which came in from Sally from New South Wales, And it was around experience she'd had with issues finding suitably graded base course materials for permeable pavements. That was in Sydney maybe 5 years ago, and she was just wondering if that had been largely resolved.
Unfortunately, I can't speak specifically to that level of detail for Sydney, either to what she would have experienced several years ago or whether it's improved to today. I guess what I probably can return back to was an element that I referenced in my presentation, that conventionally most permeable pavement based materials are leaning more towards singular sized stone, which is potentially where she was finding the difficulty in accessing material. There's a lot of, I guess, something that confuses some people is that the size range of what that singular stone should be. Is it more 10 mil or 30 mil? Different example details will lead you to different things. From the research that I've done in speaking to researchers and several experienced practitioners, is not a highly critical element in most circumstances. But one of the things that is being researched at the moment is the alignment of a more typically used base material that has a greater distribution of stone size in it, and still achieving the permeability expectations of what you'd want a permeable pavement to do. One of the elements that will do is make the material more accessible, which would assist with any legacy issue that Sally's talking about. But the second thing, the key thing that's going to open up permeable pavements to is a much greater reliability or satisfaction of them being used in heavier traffic roads, and therefore being able to get much more permeable surfaces into catchments.
Thank you. Well, Andrew, I'll keep the next question to yourself, and it's come through live. I think it's Sanjesh, maybe. And the question is, what is the cost comparison between conventional pavement and permeable pavement in terms of capital and O&M cost?
See, I had a bet with Joe, that $20 bet with Joe, that there's going to have to be a cost question. The only problem is he wouldn't take me up on the bet because he was pretty sure that we would get one as well. It depends on how you look at costs. The upfront cost of doing permeable pavement versus a conventional pavement typically sits in the realm of, and this is research based, sits in the realm of 15 to 20%. If you are looking at it exclusively as a pavement switch, you, even in the conversation of upfront costs, there are normally offsets to other elements that you can start contributing as cost offsets. I think one of the last examples I showed was the shared space laneway that conventionally would have had curbs and spoon drains that weren't installed because of the pavement technique we used. Similarly, even in the long road examples I was providing, the stormwater upgrade or conventional stormwater drainage improvement that would be required on some of those long roads is being offset by the utilisation of permeable pavements. And you don't need to do a lot of that to therefore bring that cost comparison to, I've seen examples where the permeable with the peripheral benefits is cheaper than the conventional. As soon as you start looking at life cycle costing and life cycle benefits, the permeable pavement solutions will typically come in hands down ahead of the conventional. Now there is others I've seen others present. There are reports and investigations. There's a report called The Cost of Paving from the UK that I've seen referenced several times, that talks to that same story about the cost comparative between conventional and permeable.
Awesome. Thanks, Andrew. We had a couple of questions which have come through, and I've just got to find it. I've got too many questions going open at the moment, so bear with me while I find it. But it was around, that's what it was. It was around ongoing maintenance. So hoping, and I know that you touched on the designing for tree roots. But we've just, if you could maybe both of you just address maybe some of the ongoing maintenance with regards to the permeable pavement and also the premature failure. So I don't know, who wants to go first?
So, being on the local government front, I sort of alluded to before, we don't do much more maintenance to our permeable pavements from a frequent effort. So our street sweeper going through and street sweeping, slightly different technique to normal street, is the core day-to-day maintenance. There is that point in time, as like a conventional road pavement would get to, where you need to resheet the road surface. There will be a point in time where, and probably not in the same regime as resheeting, but potentially a bit longer if you're in a pretty typical environment, where you'll need to lift the pavers, clean the sediment, and put them back. It might be a little bit more labour intensive than resheeting of a road, but from a materiality perspective, it is actually less expensive from a materiality, because you're not ripping out asphalt and having to reset new asphalt. Your materiality in picking up the bricks and relaying them is realistically, 90% of the bricks you rip up you would reuse, 10% replacement, and a few buckets of stone. From that perspective, you're sort of on a bit of a win. I don't know if Joe wanted to add anything to that question.
You look, again, it comes down to the structural design of the pavement. So you want to be designing it to obviously take in not only your construction load, so that you don't achieve dealing with early failures, but also your long-term service loading. So it's no different to a normal pavement design. You're designing it for structural strength, and if you're doing that, then you've got a pavement for a long time. I think you've covered everything else, Andrew.
Awesome. Thank you both. Joe, we've had a question which was around how can you design a permeable paving system to infiltrate 1% AEP stormwater runoff? I assume you are designing the system with inlet pits to capture 1% runoff and store the volume within the storage.
Okay, so generally these pavements do have a high infiltration capacity within the pore structure itself. Your underlying soils might not have the same infiltration capacity rate, and that's where the limitation occurs. But by the very nature of the way the pavements work, you're going to get slow progression of water through the pavement to your subgrade. So it's a difficult question to answer as such. But look, in terms of putting in inlet pits, you'd probably end up doing that anyway to future-proof the project, the design, but also it provides the ability to connect your subsurface network. From an asset perspective, if you have pits that are visible, you generally understand what the layout looks like on the surface, because you've got interconnecting network which are connected by pits. So look, again, it depends on your subgrade conditions and the ability to infiltrate. That will kind of dictate whether you're going to have inlet pits and where you position them. So yeah, it's a difficult one to answer. It's part and parcel of normal drainage design.
Awesome, thank you. Look, we have pretty much run out of time. So what I thought I might do is pose one final question to you both. And it was really just around, I suppose, what key takeaways or key messages that you'd like to stress from your presentations to the audience watching today. So what I might do is I can just go in order of speakers. So who's ready? Maybe Joe, are you ready to go first?
I am.
Awesome.
Hey, look, this is a design technique. It's part of toolbox of water sensitive urban design. It's an effective tool, particularly where you're dealing with urban infill and you've got those impacts on existing areas that are prone to flooding in those older, established inner suburban areas. That's where the pressures are really occurring. So it's an effective tool. A lot of people, I think the uptake is slow because people are scared to adopt this sort of technology. But, it's been around for a while. There's a lot of information available from particular manufacturers that can help guide you through the design process. There's a lot of research papers as well, particularly for the likes of Professor John Argue, the late Professor John Argue, and Professor Simon Beecham. There's a lot of information around. I think it takes a bit of a willingness on the individual to research that information, get your confidence up, have a look around and see what's been implemented on various projects, and you'll see that it's generally standard practice, in my opinion. It's not a difficult thing to adopt. I think it's just a willingness or hesitation based on people perceive it to be a new technique. It's not a new technique, and you can see from both my examples and Andrew's as well. It's been widely adopted in a lot of different situations. So it's quite a flexible tool that you can deliver quite a lot of outcomes from using it. And that's pretty much what sums up what I want to say. Thank you.
Awesome. Thank you so much, Joe. And Andrew?
I guess if people have been listening along the journey, they would pick up number one rule: ditch the geofabric if it's underneath the paver level. By all intents and purposes, wrap the perimeter of your excavations with geofabric, but ditch the fabric under the paver. Otherwise, you'll wear the issue of that later. Joe mentioned Professor Simon Beecham. I have the pleasure of presenting on permeable pavers with him quite frequently, and I'll pick up a couple of the things that take-home messages from his presentations that I'll borrow in his absence. Australia, in the early parts of the permeable pave story, were international leaders. Yet today we've fallen well behind with the uptake of permeable pavers in Australia, whether that be legislation, whether that be a failure of education of engineers, unsure. But you look around the world, there are many places around the world through Europe and others where you almost say by country, you can't build a car park to a Woolworths shopping centre or a Big W shopping centre unless it is permeable. You just cannot do it. There's no conversation. They must be permeable. We've fallen behind from that perspective. When we talk about where we use permeables and what they offset, roads, parking areas, they are single-use landscapes in our conventional. If we brick pave them, conventional brick, bitumen or concrete, they're single-use landscapes. And particularly for our inner urban areas where the pressure on real estate, every square metre of parcel of land in our urban areas becomes more and more valuable. And we need to think about how we get multiple facets and uses out of that real estate. And that of its own accord should be the number one driver. It should drive legislation, but that's an entire different presentation. It should be the number one driver for the use of permeable pavements in these areas. We need to take the blinkers off as engineers and stop thinking about the fact that we were tasked with designing this road pavement as part of a larger project and only looking at the road pavement. Permeable pavements are never single functionality. They give us the trafficable surface in most examples we've been talking about. They, by default, improve water quality. They by default, if they drain through, by default, they flatten the hydrograph of the catchment, even without doing anything overly special in the design of the permeable pavement. But they have such simple and cheap return flexibilities to provide multiple benefits. A single car parking space permeable pavement on a residential driveway, slightly deeper than what you'd need for a conventional design, provides about 5,000 litres of water storage. Given the penalty cost of going a little bit deeper in the permeable pavement, you would never be able to buy a 5,000 litre rainwater tank for the value of that. So that multifunctionality, the necessity in our cities to be able to start thinking about everything from a multifunctional perspective, should be the driver to uptake. That's my take-home message.
Awesome. No, thank you both. They're both excellent messages, final messages. So, look, that is all the time that we have for today. So please join me in once again thanking our speakers, Joe Laspina and Andrew King, for their time and input. I'm also pleased to confirm that we will have more events like today's session planned in 2026. The next webinar in the series is actually scheduled for the 12th of February, and that one will focus on commercial hard stand design. So I would like to take the opportunity to thank Engineers Australia's industry partner, Brickworks, for their support. Now, as I always do, we would really appreciate if you could take a moment to complete the short feedback form, which is linked in the description box below. That input, it really does help us to improve and plan future sessions for you, our audience. Finally, thank you again for joining us today, and we look forward to seeing you at our next Industry Partners event. Good afternoon.